Now we're going to start talking about the basics of experimental design. First of all, this is a typical diagram for an experiment. You're going to have subjects. They go into the hat. They're randomly assigned to different groups. Here I just have two groups, group one and group two. And each group is going to receive a different treatment. So we impose a treatment on the group. We have a control group to ideally create a baseline, and we keep other variables the same for all groups. One thing that's important is we create groups from subjects to distinguish results from chance. So that's the whole point here is we're creating replication to account for that. Then we're going to compare the response variable. So let's go ahead and talk about some of these terms. The experimental unit is the smallest collection of individuals to which a treatment can be applied. So usually these are known as the subjects. The factor is the explanatory variable. In other words, what's causing the difference. The treatment is whatever we're applying. Now, there can be different treatments using the same factors, and I'll go over that in some examples. Now, if there are different dosages of the treatment, then these are known as the levels. Typically, the factor is associated with the treatment. So usually, like in one example, we're going to talk about fertilizers, and there are three different types. So there are three levels, and the factor is the type of fertilizer. So ideally, experiments should have a control group. This purpose is to provide a baseline so you can compare what is normal to what you're getting from the treatment. Sometimes subjects are assigned a fake treatment. The reason is if you have a control group and they know other people are getting pills, they're going to feel not as, well, actually, it's the other people getting pills that's the problem. They're going to take the pill, and even if it's a sugar pill, they may think they're doing better. In fact, placebos are like the most effective treatment out there. They help everybody because of something called the placebo effect, which is primarily psychological. They say, ooh, I took a pill, I feel better. Kind of like when your mom kissed your boo-boos. You're like, oh, it still hurts, but you feel better because mom kissed it. All right. So by randomizing and using placebos, when possible, we can control for the impact of lurking or confounding variables. On the AP test, we primarily use the term confounding variables. You don't tend to see the word lurking anymore. I guess it was too, I don't know, sinister. Blinding prevents bias by hiding the treatment type from the observer and or the subjects. And if you blind one side, it is single blind. If you blind both sides, it's double blind. And so the reason we might blind the subjects is we don't want them to have some sort of psychological, oh, I feel better. And there's also a good reason to blind the observers. In some senses, for example, if a teacher thinks that a student has a higher IQ, they actually tend to grade them higher without meaning to. They tend to also motivate them more, and they tend to teach them more. So as a teacher, we try to blind ourselves and treat all of you equally, and so that we don't have a disparity in how we teach among you. Double blind is when neither the observer or the subject can see the treatment type. One of my favorite examples of a double blind is on Grey's Anatomy. They had this treatment, I think it was for cancer. And the doctors would assign they would give the treatment, but they didn't know which one they were giving to the patient. And the subjects also didn't know which one they were giving. So they actually one of the doctors broke in and she switched it because she wanted to make sure her subject was getting the treatment because she was hoping it would help her subject. Okay, now a key principle of random assignment, and we're going to go into this in the next lesson in more detail, but all subjects must have an equal opportunity to be assigned to any of the treatment groups. The purpose of randomization is to create comparable groups. So if your method of assignment kind of prefers the people in front or a certain group, they're not going to be as comparable. So where the effects of confounding variables should be roughly the same. Now, confounding occurs when two variables are associated in such a way that they're affecting the response, and you can't tell if it's a treatment causing the response or this other variable. So to validate the results of an experiment, it is always important to replicate the experiment to see if they are repeatable. Here's an excellent example. So this is true. In 1992, there were several observational studies of women who took hormones and those who didn't. And they noticed that women who took hormones had less heart attacks than women who didn't take hormones. But then in 2002, they did several experiments to say, hey, okay, this hormone thing, is it helping? And they found out, no, it actually has no impact whatsoever. So first of all, what is the difference between the 1992 studies and the 2002 studies? Well, the first one in 1992 was an observation. It tells you here, observational study, right there. The other study was an experiment. Well, how can we tell what does that mean? How are they different? Well, in an observation, subjects choose. They don't get to choose in experiments. So what was the confounding variable and why did it influence these studies of 1992? Well, think about it. A woman who has to go see a doctor, she's going to take hormones. Women who don't see doctors are probably less health conscious and more likely to get a heart attack than women who don't. All right. In fact, I was just at the doctor today because I see my doctor regularly. All right. Two more examples. We have a farm product manufacturer wants to determine if the yield of a crop is different when the soil is treated with 3 different types of fertilizers. 15 similar plots of land are planted with the same type of seed, but are fertilized differently. At the end of the growing season, the mean yield from the sample plots is compared. So what are the experimental units? I'm just going to say the plots of land right now. Those are your different subjects. The factor, well, it's going to be the type of fertilizer. How many levels? Well, we have 3 types of fertilizers, so we have 3 treatment groups in that. What is the response variable? We're trying to measure the mean yield. All right, so if that's better, we're going to guess the fertilizer is better. How many treatments? Well, I only pretty much have 3 types of fertilizer, so that's how many treatments we have. Now, why do we use the same type of seed on all 15 plots? Well, we want to make sure that we're trying to minimize confounding variables. So different types of seeds may have different types of yields. So we're trying to control for the type of seed. Last example. A consumer group wants to test cake pans to see which works the best, bakes evenly. It will test aluminum, glass, and plastic pans in both gas and electric ovens. So what are the experimental units? Well, the thing I'm going to be looking at are actual cakes. All right, so I'm going to take a look at them. The factor is, well, there's 2 really, the types of pan and the type of oven. All right, how many levels? Well, we have 2 different ovens and 3 different types of pans. So we have 2 for one, 3 for the other. What is the response variable? Well, we're going to check which one bakes evenly. So the evenness of baking is the response variable. How many treatment groups will I need? Well, I'm going to need 3 pans in one oven and 3 pans in the other. So I will need 6 treatments.